All right, welcome to hydescience.org. Today we're going to be talking about balancing chemical equations. Start off with something real simple that most people don't have trouble with, and then we're going to talk about one of these in which our physical science kids, they're unfamiliar with polyatomic ions yet because it just hadn't been part of their standards to learn up to this point, but we still need to be able to balance equations such as this. So I'm going to show a way to kind of break that down and get that done. Starting off first, just kind of a review of how we do things. The first thing we're going to do when we go to balance the equation is we're going to split the equation between our reactants. Here's our reactants on this side. These things react together to form our products. All right, then we're going to make a list of the atoms we have. We have a hydrogen atom on both sides and an oxygen on both sides. There are two hydrogens and there are two oxygens. There are two hydrogens here, but there's only one oxygen on this side. So what we have here, these things don't balance. So in order to make them balance, we got to add coefficients. And too often when we add the coefficients, we don't really understand what they're doing. So we're not going to add coefficients first. First off, we're going to add more compounds to see if we can balance it out that way. So we need more oxygens over here. So I cannot just add an oxygen. If I put a 2 over here, that's not oxygen anymore, that's hydrogen peroxide. And that is not a necessity of life, like water is. So what I'm going to do is I'm going to add a whole nother water over here. By doing that, now I have a total of 2 oxygens and 4 hydrogens. So now that my oxygens are balanced, but now my hydrogens are not, I need to come back over here and I need to add another hydrogen atom or molecule. And now I'll see I have 1, 2, 3, 4 hydrogens. So now that my chemical equation is balanced, now we can put in our coefficients and hopefully we'll understand what they signify. I have 2 hydrogens right here. So I can put the coefficient 2 to represent there's 2 hydrogen compounds there. I still only have 1 oxygen compound, so I can put a 1 in for my coefficient. But if we don't write the 1, it is understood there's a 1 there anyway. Over here I also have 2 water compounds, so I can put the coefficient of 2 there to balance my equation. Too often we try to worry about what's multiplying in here is going to do to balance it out. And that's a quick way, and that is definitely an easy way. But it's important to understand that this 2 doesn't signify multiplication. The 2 signifies that there is 2 hydrogen compounds that we need in our reactants. All right, moving on. When we're handling these big situations, these bigger chemical equations than what we're used to, our first step is still the same. We're going to split our equation between the reactants, and we're going to split them between the products. Because according to the law of conservation of mass, everything we have in our reactants must be equal to everything we have in our products, because matter cannot be created or destroyed. It can only change from one thing to another. After we do that, we're going to make our list. Copper, and then we get to this. This is called a polyatomic ion. It's something that we're not familiar with. But if we assume that everything that is, has a bunch of stuff in it is a combination of 2 things at this level, we can split our compounds. And after each first element, so copper, then I split it. Sodium, split it. Sodium, split it. Copper, split it. I could probably pair what is left over with each other. So I have a PO42 here. I want to see if I can pair it with anything else. Here I see another PO4. So these are exactly identical down to the subscript. All right, well, we can't put that 2 in there, unfortunately. Capital P, capital O, 4, capital P, capital O, 4. So these are identical. So what we're going to do here is we're going to combine them together, and we're going to treat them as one thing. Moving on, Na2. We can't use the 2, I'm sorry, because we got 2 and a 3. So unfortunately, just leave that Na. Then we get to sulfate, S, capital 0, capital 4, capital S, capital O, capital 4. We're going to pair these together and treat them as the same thing as well. All right, now we've made our list, we're going to go through and we're going to count how many we have of each one. All right, I have 3 coppers here. I have 2 phosphates, 2 sodiums, nothing out here, so just 1 SO4 all by itself, 1 sulfate. I have 3 sodiums, no subscript out here, so I have 1 of these phosphates here, 1 copper, 1 sulfate. All right, now we're going to kind of treat this the same way we did a while ago. We're going to make them balanced. We're not going to add coefficients till the end, just to make sure we understand the purpose of the coefficients and what they do. Our general rule, we save oxygen and hydrogen for last. We have no sole oxygens or hydrogens here, so it doesn't matter really where we start. All right, let's just start at the top. We have 1 copper and 3 coppers. So we need more copper in our products. So I'm going to add another compound that contains copper in it. So I'm going to add another CuSO4. Now I have 2 coppers and I have 2 SO4s. This is not enough to balance my copper, so I need to add another compound with this copper in it. So I got CuSO4, I'm going to add another one. I have 3 total compounds now. 1, 2, 3. 3 coppers. 1, 2, 3 sulfates. I put SO4, I didn't even let me know. Okay. So now my copper's balanced, but in the process of doing that, I got these out of whack. So really we can go kind of anywhere we want to. Again, I'm just going to stay on the same train I was on, same tracks, try to make these balance out. So I need more sulfates over here. So to do that, I'm going to add more compounds with SO4 in them. So now I have 1, 2, 3, 4 sodiums. And I have 1, 2 sulfates. That's still not enough. I'm still not balanced. So I'm going to add another Na2SO4 here. So now I have 1, 2, 3, 4, 5, 6 sodiums and 1, 2, 3 sulfates. Now these balance, these still do not balance. All right. So I need more over here. So I don't know how many more I need, but let's keep going. I'm going to add another compound here, so I need to add another Na3PO4. So now I would have 1, 2, 3, 4, 5, 6 sodiums, and I'd have 1, 2 phosphates. Okay, now I take a look at what I have left. 3, 3 match, 2, 2 match, 6, 6 match, 3, 3 match. Now everything is balanced. Conservation of mass is happy, or approved, supported, however they want to say it. So, but unfortunately this is not an acceptable answer. We must have coefficients to be an acceptable answer. Well, I didn't add any more compounds of copper, so my coefficient is just 1. And again, 1 is understood. You don't have to write anything there. Now here I have 1, 2, 3 of these sodium sulfate ions. So I'm going to put a 3 here. Okay, that my coefficient represents that. Over here I have 2 of these. So I'm going to put a 2 here that represents there's 2 of those compounds. Here I have 1, 2, 3. So putting that 3 in represents that compound. This is our acceptable balanced equation and our answer. I hope you've enjoyed this episode of hydescience.org, and I hope you're a little bit better at balancing chemical equations than you were before watching the video.